Now, in the last episode, I said we were going to look in this episode at getting some outputs from our computer, but actually I'm going to go off on a little tangent first for one episode, which is that when we programmed our ROM, if you remember, what we had to do was we had to physically type in all of the opcodes that we wanted to use into the ROM and then program the ROM. And that's fine for simple programs, but pretty quickly that's going to become difficult. And, there's a reason that nobody does programming this way. We have to remember to put in the bytes in little Indian format, and we have to remember that the ROM is out from the computer, both an address, with a sort of offset of 8000 hex, and so on and so forth. It's an absolute faff. So it would be much easier if we could use a piece of software just to type in the program, type in the LDA 9000 and ADC and blah, 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 just directly. And it turns out there is software that will do that. It's called an assembler, and there's loads of them available. But the one that I'm going to use is called VASM. Now, before we get there, actually, this needs to use the Windows PowerShell. And what that is just simply a text way of controlling your computer. So, yes, it's lovely that Windows has got, point and click and has got a, file menu and a cut and paste and blah, blah, blah. But sometimes it's just easier to use the keyboard only. So I'll give you an example. I'm going to make a directory to put all of my files in. Okay, so mkdir, let's make directory, and I'll call it 6502 because that is the type of processor we're using. And if I type list ls, then it'll give me a list of all my directories, and look, we've got the directory 6502. So that's very nice. Now, I said we were going to use VASM. If you do a Google search for VASM, you will find it, or I will leave a link in the description as well. And so why am I using this particular assembler? Well, it will cope with the 6502, so that's good. It will do old 8-bit style syntax, so that's good. And it will output a raw binary file, which is what we want to put onto our ROM chip. So all of those are excellent. So how do I get a hold of it? Well, what I do is I go to the last release binaries. Oh no, hold on. Sorry. I'll go to Volker's VASM page. He's one of the guys who wrote it, and in fact, he's got binaries of VASM for Mac, Windows, and Linux. Now, I'm using Windows, so what I will do is I will download that file, and then let's have a look at it. This has actually already been compiled into the old style of syntax, and it's for the 6502, so that's perfect. Let's go and have a look at Windows. Okay, and all we need to do is we need to copy these 3 files, Control-C, and then we'll go and find my 6502 folder, and we'll paste them in there. And that is the assembler downloaded. Fabulous. Now, the assembler itself won't let you write code into it. You need some sort of a text program, so you could do it with Notepad, you could do it with Word, as long as you saved it as a text file, but I like Notepad++, and there's a good reason for that. So Notepad++, again, I'll put a link, you can download it, it's just a piece of software, but it has the ability to select a language, in this case 6502 assembly, and that will sort of help you write the program and colour different things in different colours and just make it a bit clearer. Now, it doesn't come with 6502 assembly pre-installed, but if you go to user-defined language and then go to the user-defined languages collection website, it's got quite good instructions on how to download it and how to select the 6502 language. So that is in fact the language that I'm using. Okay. So let's go back and write out the program that we had done in the last episode, but we'll do it in this format. Now, first things first. For some reason, well, for a reason which I'll explain later, all of your commands need to start with some space at the beginning, a tab or some spaces, whatever. But do you remember we started with CLC? Okay. And then we had load A, and we were going to load it from 9000, and the nice thing is, now, just one thing. We're dealing with hex numbers, so we have to put a $sign, 9000. Now, otherwise it would try and load it from decimal 9000, which goodness knows where that is. Now, one nice thing about this program, of course, is that we are now going to only address things from the point of view of the processor. So the fact that the ROM chip is in the second half of the address space and it's not really 9000, it's 1000 and blah, 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 blah. Okay, we can ignore all that. That's going to sort that all out. Okay, the next thing, if you remember, was ADC, and that was $hex 9001. And then the last thing we did was store and that we stored it in 4026. And that is a lot faster and easier, especially when you get big long programs. Now, we're not quite done yet. You see, we haven't told it where in the ROM to put all this. So we can use things called dot directories. So, and what they are, there are commands that start with a dot, and the simplest one is org, and just means you can tell it where it's going to start. And from the point of view of the processor, it's going to start at 8000. Okay, there's our program. Now, also, do you remember we needed some data, and it was going to start at 9000. So let's jump up to 9000. Okay, and now I need to put in some data, and I can't remember exactly what it was. We're going to put in two numbers, weren't we? So to put in a number, you can just use the command .word, and starting at 9000, it will put in our two numbers. So let's have a look. We wanted to add two numbers together. Now, this is going to put in a 2-byte number. So we can actually just put, let's say we wanted the first number to be 3C and the second number to be 52. You can just do that. And what that will do is to put in 3C at address 9000 and 52 at address 9001. Done. Right, and then the final thing is, do you remember that we had to put in the reset vector? And the reset vector gets put in at FFFC and FFFD, like that. And again, we can put in and the address, which is 8000, no having to put it in backwards or sideways or whatever. And that's it. That is our program. So we can save that. Can you see, by the way, that if you set it up with the language, it's quite nice. It's coloured the dot directives red. It's coloured the addresses. Oh, and look, this has picked up a problem already. I forgot to put in a $sign there, so it thinks that that is, oh, Christ knows what it thinks it is, but it doesn't think it's a hex number. Now it does. So that is a really good example of why having the notepad know what language I'm trying to use is a good thing. Okay, let's save this as adding. Okay, and we are going to save that in 6502. Okay, and I'm gonna give it a suffix adding.s. Okay, and that's that. So now we can go and we can use our assembler. So go back to our PowerShell. Right. So we're going to change directory to 6502, and let's see what we've got in the directory. We've got adding.s, and we've got our assembler phasm6502_oldstyle.exe. Now, one nice thing about the PowerShell is that if I want to run a piece of software, I don't have to type in VASM6502_OLDS. Right, I can just type in phasm and press the tab button, and it finds the thing I was after. As long as there's not more than one of the things, it will find it. So, I have to put in a few arguments here. So if I just try and run it like that, it will complain that no input file has been specified, which is fair. So sometimes if you want to do a thing, it's you know, a good idea just to try. Here's the second trick you can use with PowerShell. If I press the up arrow, it just brings up the last command I used, which I can now adjust, and I can put in the program I would like it to compile. Now, it still doesn't like that very much. Okay, it says unknown mnemonic, and that's because I haven't told it that I want to use the .directory command. So let's try that again, and we shall put in the using the .directory argument. So you do that by putting in -dir. Okay, and it has compiled. Now we're not quite done, because let's have a look at our directory. It always creates the file. It's called a.out, and if I have a look, I'll do cat a.out, it will show me things about it. And what that is a text file. Okay, and can you see it's got all our data, that's great, but it's got words like data in it, and it's got section seg A000, and okay, that's not good enough. We need literally a whole bunch of zeros until the right place, and then our AD0090, whatever. Okay, so we're going to put in one more argument. Okay, we're going to go and then we're going to tell it that we want it in a binary format, binary. Okay, so now our command reads use VASM, format in a binary way, .dir, which we're using .directory, and there's the file that we're using. If we do that, it then builds. Fabulous. And there we are, there's our a.out. Now with a bit of luck, that we can use. So let's see if we can. Let's go back and open our XG Pro. Okay, there's not actually a ROM in here, but there's a sort of pretend ROM. So we could file, load file. Let's find our file name. Okay, and let's see what happens. Okay, now firstly, let's go and have a look at the beginning. We've got all the program that we wanted. We also, do you remember we need to look at 1000 and see if we can find anything useful at 1000? And yes, we can. Look, we can find our 2 pieces of data. And then finally, let's go and have a look right at the end at FFFC and FFFD. Okay, and look, we have got our reset vector all ready to go. Okay, isn't that brilliant? We have just made our ROM chip exactly as we did before, and now we can make more and more and more complicated programs and not have to physically program the ROM. So, I hope you enjoyed that. I shall see you next time for another episode. Goodbye.